This is 5-5 part 3, not 5-3, 5-5, but it is part 3. So the only other thing we haven't done in this section are the half angle formulas. If you went back to the title of the section, it was double and half angle formulas. And so here they are, half angle formulas. Yet again, more stuff that you would want on a cheat sheet whenever our next quiz is. I don't have that scheduled yet. But here's the first one. It says sine of u over 2 equals plus or minus a big old square root of 1 minus cosine of u all over 2. That entire fraction is under the square root. So make sure on your paper it doesn't look like the square root is just on top. It should be around the whole thing. Okay, got another one for cosine. There you go. Yep, this is part 3 of 5-5 that we're just starting. Cosine of u divided by 2. That is going to equal plus or minus another big old square root of 1 plus cosine of u all over 2. You'll notice the only thing that's really different between those is the minus right here and the plus right there. Everything else is the same. And I should also point out before I give you tangent that this part right here makes these half angles. U divided by 2, or it might be theta divided by 2, or x divided by 2. When you divide something by 2, you're taking half of it. So that is why these are half angle formulas. Now I should also point out something about the plus or minus sign. And I just wrote this off to the side. The plus or minus depends on the quadrant. The plus or minus depends on the quadrant. So sometimes it's positive, sometimes it's negative. We will talk about that a little bit more later. And then look down here at tangent of u divided by 2. There are 2 different ways you could solve it. You could take 1 minus cosine of u all over sine of u, or sine of u divided by 1 plus cosine of u. Either way, whichever one you choose to use, it should give you back the same answer. Now, believe it or not, I'm actually going to add to this list for tangent. You already have 2 ways to find it, but here's a third way, which is something that we did a little bit yesterday. Remember the quotient identity. Tangent is sine over cosine. And so another way to solve this would be, I'll try and squeeze it in down here, would be to take, these are u's, sine of u divided by 2 all over cosine of u divided by 2. If you already know the answer to this part and the answer to that part, then you might as well just keep change flip, and then that would give you back tangent. I'll show it to you both ways today, just in case you get to a problem later where you don't know those ahead of time. You do still want to know how to work with those formulas. Okay, so big star next to these. These are going to be good to have on a cheat sheet. And directions and the figure are going to be good for the whole lesson today. It says find exact values bottom left. This is not drawn to scale. The side on bottom is 12, and it looks shorter though, and then the side on the right is 5. Now each problem is going to be different. They're going to ask you for different stuff in each problem. So I can already look at this triangle and I already kind of know that I'm probably going to have to find out what this side is. That's the side that they didn't give us. And that's the hypotenuse. So as I run through my Pythagorean theorem, I'll figure out what C is. I've got 12 squared plus 5 squared equals C squared. That is 144 plus 25, which is 169. And hypotenuse is always positive, so you don't have to worry about the plus or minus 13. You just want to keep 13. That is the hypotenuse. Okay, you didn't have to do that first, but I like to do that. I'll probably need it here in a second anyway. So, example 1, cosine of theta divided by 2. I know this is a half angle because it's theta divided by 2. So, I'll go back to my formula, and I actually just recopied the formula up here. It's plus or minus square root of 1 plus cosine of theta all over 2. Everything is under that square root. So let's just take that formula and start to plug in some stuff and simplify it. Now I want to talk about the plus or minus sign. Remember I said earlier that always depends on the quadrant that you're in. If you look at this triangle, and if you have handy dandy in front of you, that might be kind of helpful as well. Looking at those triangles, which quadrant does this triangle look like it's in? Quadrant 1. It's set up like a quadrant 1 triangle, and that is good because everything is positive in quadrant 1. So I'm just going to make a little note here. We are only going to keep the positive square root because we are in quadrant 1. Keep the positive square root because we are in quadrant 1 and everything's positive in quadrant 1. Spoiler alert, all of your triangles will be in quadrant 1 today, even in your homework. So, I mean, for the most part, you can just not worry about that plus or minus sign. Know that it will always be positive. Okay, so I'm leaving that off. Now I start to plug in all my stuff under that square root. Now, on top, I need to take 1 plus cosine of theta. If you look at this triangle, what is cosine of theta? 12/13. So this looks a little awkward with the fraction in a fraction, but I've got to take the square root of 1 plus 12/13 over 2. Now to add those numbers on top, since this is a fraction, you really do have to get common denominators. I would think of the 1 as 13 over 13, and then I can add those pretty easily. 13 plus 12 is 25/13 all over 2. This looks weird, but now under the square root still, I'm going to keep, change, flip. Okay, I've got my square root there. Keep the 25/13, change it to multiply, and flip the 2. So that now becomes 1/2. And if we multiply across the top and across the bottom, I have square root of 25 over 26. Now, unfortunately, we're not quite done. We do want to take that fraction and simplify it a little bit further. Any questions up until this point? The reason we want to simplify this a little bit further is because square root of 25 is nice. Let's break that square root apart. Take the square root of 25 divided by the square root of 26. Now this just becomes a 5 on top. No more square root symbol. And for the time being, I left the square root of 26 on bottom, but we should rationalize that because we don't want to leave a square root on the bottom of a fraction. So we will write our answer as 5 square root of 26 all over 26. Okay, everything is quadrant 1 today. Ruin that surprise for you. So the plus or minus is not going to be an issue. We can keep everything positive. Okey-doke. I'm going to go ahead with the next one. Stop me if you have any questions. Same triangle at the top, but now I need to know sine of theta over 2. Sine of theta over 2. The only difference in our formula is the minus on top. It's not going to have plus or minus out front. I'm going to drop that off here in a second. Just keep the positive square root. And now, under the square root, it's going to be 1 minus 12/13 all over 2. So again, think of the 1 as 13 over 13, and once you subtract, you get 1/13 divided by 2. All of that is still under the square root, but underneath it now says 1/13 divided by 2. So let's keep change flip again. This is going to be the square root of 1/13 times 1/2. So across the top and across the bottom, it becomes the square root of 126. So let's do what we did on the last one. Break the square root up into the top and bottom separately, because square root of 1 is just 1, and now I can rationalize that. I'll take the top and bottom times the square root of 26. So, square root of 26 over 26. That is sine of theta over 2. Any questions about how we got that? It's a lot of the same steps as the last problem. Again, you're just subtracting instead. Now, for number 3, you probably know what's coming. We've already done sine and cosine. So, number 3, we got to find tangent of theta over 2. Tangent of theta over 2. Okay, I'm going to show you how to do it using that formula first. And then here in a second, I'll show you how to do it using a quotient identity. If you are just doing the quotient identity, I will suggest that you use the fractions from earlier that haven't been rationalized yet. It works out a lot nicer if you do it that way. I'll show you that here in a minute. But let me first show you how that formula works. And I think I'm just picking the first one. 1 minus cosine of theta all over sine of theta. The cosine of theta was 12/13. Sine is opposite over hypotenuse, so that is 5/13. And again, I need to think of this as 13 over 13. So once I subtract, I get 1/13 divided by 5/13. And I can keep, change, flip on that. The 13s should drop out and you just get 1/5. Okay, now doing the same problem but with the quotient identity, I'll show you how this works. Sine of theta over 2 divided by cosine of theta over 2. Now, my final answer from sine was square root of 26 over 26. You can put that here and that is just fine. However, I kind of like to use it the way it was before it was rationalized. It just seems like it works out a little bit nicer. It's a little bit easier to cross stuff out. Same with cosine of theta over 2. The final answer was 5 square root of 26 over 26, but I'm going to use the fraction before it was rationalized, because watch how quickly things cross out, and you would still get this answer if you didn't use these fractions, but now those square roots are gone and you just got 1/5. So same answer, just two different ways to do it. Okay, any questions about finding tangent of theta over 2? Okay, well, we've done the hard part. There's a few more problems here, but that one shouldn't be first. And let's go ahead and write this out then. I switched the order during the passing period and apparently forgot to change my animations. Let's go with number 4, cosecant of theta over 2. Let's do this one next. Cosecant of theta over 2. Do we have a formula for cosecant of theta over 2? No, but cosecant is the reciprocal of sine. So why don't we flip over our answer from sine of theta over 2. And that, well, let's see here. Again, it might be helpful if you use the fraction before it was rationalized. Sine, before it was rationalized, right before, was 1 over square root of 26. That is going to be a whole lot easier to flip. If you flip that over, it's square root of 26 over 1, which is just square root of 26. So that worked out pretty nicely. Okay, I'm going to do one more like this. Let's do secant of theta over 2. Secant of theta over 2. Now, secant is the reciprocal of cosine. So here, we're just going to flip over the answer that we got from cosine of theta over 2, but I'm not going to use my final answer. If you used your final answer, you'd be flipping over 5 square root of 26 over 26. That doesn't sound like fun. Let's flip that fraction over, and it's a whole lot faster. That would be square root of 26 all over 5. Okay, may run into some reciprocals, so I just wanted to show you that. Now, I think there's 2 more problems here. So 6 and 7, this will be our last couple. Number 6 says 2 sine of theta over 2 cosine of theta over 2. There's like 3 parts to this problem. I'm going to pull down the 2, but now I have to plug in what sine of theta over 2 is and what cosine of theta over 2 is. Now, when I do this is like the 7th time I've said this today, I like to use the fractions before they were rationalized. If you go back again to sine of theta over 2, it was square root of 26 over 26, but right before that, it was 1 over square root of 26. So that's what I'm going to use. And then next part here, cosine of theta over 2, I need to plug in, I wouldn't go 5 square root of 26 over 26. I would just go 5 over square root of 26. It's like what I showed you the other day. If you use these fractions, then they pretty much rationalize themselves. Square root of 26 times square root of 26 is just 26. And I think you get a 10 on top. So you would want to simplify that. Just turn that into 5/13. Okie doke. Not too bad. Now, last one. Number 7, cosine of 2 theta. Cosine of 2 theta. Now, hang on a second. Cosine of 2 theta, that is a double angle, not a half angle. They're trying to trick us. If it was half, it would be divided by 2 like this. This is multiplying by 2. So actually, we kind of have to go back and use one of our formulas from yesterday or the day before. And I always go with that first one on your list, although any of them would work. It's cosine squared of theta minus sine squared of theta. Now here's what's tempting. I'm tempted to come back up here and use this fraction for cosine and that fraction for sine. However, those were half angles. This just wants plain old cosine of theta squared. If you come back to your triangle, cosine is 12/13. So that's what you need to square first. Minus sine, which is 5/13 squared. You can't go back and use a half angle on this problem because you don't want half angles. Now, I'll take 144 divided by 169 minus 25 over 169, and I think that gives you 119 over 169. Now, I'm not sure if they try to trick you like this in your homework or not, but this is just to kind of let you see the difference here between half angles and double angles. Any questions about those? All right. Now, the assignment is up here, and there's a couple more things I need to tell you. But this is T45 from page 391. We're just doing 49 and 50, although they do have several parts to each one, so may take just a little bit more time. And I did say watch for theta on number 50. I think it's up in the right-hand corner again instead of down where it usually is. But still go ahead and assume that you're in quadrant 1 on number 50. So still keep just the positive square roots when you go through your formulas. And then don't forget, I mentioned this yesterday, but tomorrow in class, We're gonna do our Project Excel surveys if you haven't done them already. So before class tomorrow, track down your MyVU username and password. I want you to come to class ready to go. That way we can just do that real quick and then that'll be about it tomorrow. So track that down. If you need some help with that, let me know.